Hi, today I'm going to be talking about optimization. We're going to do a bunch of problems. Optimization was chosen by popular demand as something that you guys struggle with. Please take your time watching this video. Every single time you see a problem, you should pause the video, write down your solution as far as you can take it, really try, and then check my solution. So here's the 4 or 5 basic steps. We're going to choose a variable, draw a labeled figure, write a primary equation, try to isolate whatever's going to be maximized or minimized. We only want one variable on each side. This might require a secondary equation. Then I will find the domain. And that's really just in case I want to make, or just because I want to make sure I'm not over searching. I'm not looking for extraneous solutions that won't be helpful to me. Then I'm going to take the derivative, find the critical numbers, make a number line, and bada bing bada boom. Here we go. Alright, example number 1. A box with no lid. 48 centimeters square of material. If the box has a square base, find the dimensions. Explain the meaning of the answer with a complete sentence. I'm mostly focusing on the math, not the writing of the sentence. In a few problems I'll do the sentence, but just in the interest of time because there are 17 problems. Pause the video, try it out, see what you can do. Pretend like this is a test question. What would you have written? Alright, 3, 2, 1. I'm assuming you paused it. Okay, so this is the box. It has a square base. So if that side's x, then this side's x, and we'll call the height y. Okay, find the dimensions that produce a maximum volume. My volume for this box would be x times y. Correct? Now I want to make sure I have only one variable on each side. So I would use my surface area equation, which for this box would be the bottom of the box plus 1, 2, 3, 4 sides of the box who have dimensions x, y. In particular, this box has surface area 48. How do I know that was surface area? Because it's centimeters squared. No top is very important. That's why it's only 1x squared. So I want to solve this for y. Why do I want to solve it for y? Ha ha ha. Because it's easier to replace y in this equation than x. It's also easier to solve this for y than this. Than x in this. If you wanted to solve this for x, I'll give you a quick hint. You'd have to complete the square. And that would be sucky. So here's my y. That's going to get replaced into there. Getting volume equals x squared times 48 minus x squared over x. Now I want to make a quick domain check. The domain of this function, before I simplify, that's the key, x can't be 0. And if I really think about it, not only can x not be 0, x should be greater than 0. Why? Because it's a box and it can't have negative side length. So this depends on context. not only does it have to be greater than 0, it actually has to be less than the square root of 48. Why? Because were it to be greater than the square root of 48, then all of a sudden the volume would start to be negative as well. Because then all of a sudden y would start to be negative. And that's no bueno either. Okay, so these two bounds depend completely on the context. So now I'm going to focus on simplifying my volume equation. This one. Oh, this work is crazy. We'll try to organize the next one better, huh, folks? I don't want to, as a rule, have to use that pesky product rule. Because that product rule causes you guys to have some problems. Nope, not with respect to x. We want to take the derivative with respect to x, not with respect to t. Sorry. Why am I doing this? Why? Because this is how you maximize things in calculus. From this point on, you should always be looking for the maximum point or the minimum point as coming from this type of situation. As coming from this situation where the derivative, a small change in x, produces a no more change in volume. So here I go. I got this x's, sorry. Now we want to make a number line. Open. Open. Why is it open? Because it cannot be equal to either of these. Because then the other dimension would have problems. I'm going to factor out of 3. No. 16 minus x squared. Look how I'm writing dx each time, rather than writing some half-done work. So my critical numbers were x equals 4 and negative 4. Guess which one doesn't live here? Negative 4. Now we're kind of sure 4 has to be the correct answer. It kind of has to be. There's not really any other option, but we're still going to show our work. Because the justification in terms of a sentence would still have to be 4 produces the maximum volume because at that point the change in volume goes from positive to negative. And in fact it does. Check 1 in this, oh, we get a positive. Check 5 here, we get a negative. If that helps you. Okay, so x equals 4. Y equals, and I'm plugging this into that equation. 48 minus 4 squared over 4. And to tell you the truth, y equals 8. So the dimensions of the box will be x equals 4, y equals 8. Okay. The sum of two non-negative numbers is 30. Find both numbers of the sum of the twice the first plus the square of a second is a maximum. Now this is a situation where a figure won't help you. Pause the video, try it out. 3, 2, 1. I hope you started out with labels. That's the hint I was trying to give you. X will be the first number. Y will be the second number. The sum of these two numbers is 30. We're looking for the sum. We want to maximize the sum. Twice the first plus the square of the second. So which is easier to replace in here? X is way easier to replace. So I'm going to solve for X and plug it in over here. Now let us think. Domain. Let's think about the domain here, folks. Okay, y. Is there a maximum value y could be? Is there a maximum it could be? Yes. If y became greater than 30, then x would be negative. And we know they're both non-negative. It has to be less than or equal to 30. Is equal to 30 okay? Yes, because x can be 0. That's allowed. And in fact, we know y has to be greater than or equal to 0. And both of those ends are based on that word non-negative. So both of these are possibilities. So if that's s, then s prime, I'm going to show off here and do the derivative by using the chain rule, is going to be negative 2 plus 2y. Negative 2 plus 2y equals 0. Y would be 1. Okay. Now we make a number line, an S prime number line. Notice how it'll have bracket because 0 is included and 30 is included, with 1 being my critical number, and it doesn't really matter how proportionate this looks. Between 0 and 1, S prime would be, we're thinking like a number like a half, people. Negative. Between 1 and 30, you can use 10. Any number will work. It'll be positive. So the point is, with how S prime looks, 1 is not a max. We want a maximum here. And y equals 1 is not causing a maximum. You have to see that. I guarantee you y equals 1 would be an answer. So we have to use candidate test. Not that color. So, namely, I'm going to use 0 and 30 when y equals 0. What's s? And again, that's s, not s prime. It's s, not s prime. This form is nicest. When y equals 30, this part is 0. 30 squared is 900. Boom. When y is 0, this part is 0, and that part is 60. So, max at y equals 30. X equals what? 0. Okie dokie. The next one's the same thing with minimum. Take a minute. See if you can make sense out of it. Should be pretty easy. 3, 2, 1. What our number line here shows is that this y value has to be higher than this y, or this y value has to be higher than this y value this value of the sum, this value of the sum has to be higher than this value of the sum, and this value of the sum has to be lower than this value. Now, for those of you all thinking that couldn't we have seen 30 is bigger, maybe the sum graph looks like this. Maybe the sum graph looks like this. But we can't tell which endpoint's higher. We know it has to have that shape, but we don't know which endpoint had to be higher. However, we know 1 is the lowest point. So, y equals 1, x equals 29 would be the smallest sum. 30 minus 1. Okay. Pause the video. Try this out. 3, 2, 1. X is my first number. Still have the label. It won't matter too much in here. Y will be my second. X times y equals 100. That's this equation. Sum of the numbers. X plus y. Straightforward problem. Either one's easy to solve for here. Or as easy as the other, for those of you having a hard time. I like X for obvious reasons. So my remodeled S will be X plus 100 over X. This equation has a certain domain. I'll just use pink because, that's what we've been using. The domain of this, certainly X can't be 0. But indeed, we know they're both positive. They're both positive, so X is bigger than 0. That's what it means to be positive. Does X have a max value? Well, let's just try something crazy. Like, if X is 100, what's Y? 1. That's fine. What if X is 1,000? Y is 1/10. That's fine. So, it has no max value. That's important. Okay. Now, we go about our business. S prime equals 1 plus. Your life will be easy if you can differentiate this nicely. Here I go. How did I do that so fast? Power of -1. To power of -1, take -1 down, subtract 1 from the power. S prime equals 0. That's how we're finding critical numbers. 1 minus 100 over x squared equals 0. 1 equals 100 over x squared. X squared equals 100. X equals 10 and -10. Both are solutions to this. What else would be a critical number? Zero is a critical number. S prime's undefined there. But neither of these matter. Both outside of the domain. Okay, like, those are all subtle points. The only critical number is 10. And I'm sure some of you are sitting there right now with 10 circled greedily on your paper without this corresponding work. And you need this work. That's an arrow. That's a open parentheses. Between 0 and 10, what's S prime? S prime some negative number. Try 1. After 10, S prime some positive number. So does 10 have to be the minimum? Yes. So x equals 10 is minimum. Or at least causes the minimum. Y equals 10. Done. That's it. Anything else gives you a bigger sum. It's guaranteed. Okay, next. Alright. Trying it out. You go first. Give yourself a minute. Try as much as you can. 3, 2, 1. X is first. Y is second. The sum of them is 25. I don't know what color we want the sum of the first plus the square of the second is a maximum. So what's easiest to plug in here? X. So we're going to have y's to deal with, unfortunately. 25 minus y plus y squared. Domain of y. Well, it has to be non-negative. That means greater than or equal to 0. And is there an upper bound? Well, if y became 25, x could be 0. But y certainly can't be 26 or 25.01. So it's going to be tightly in these bounds, inclusive. Inclusive. So if that's S. S prime equals negative 1 plus 2y. S prime equals 0. Y when y equals 1/2. So I'm making the number line with included endpoints 0 and 25. 1/2, anywhere in the middle you like. After 1/2 is really easy to check. We're plugging in things like 1, people. Before 1/2, guys, I'm going to let you in on a little secret. You can plug in 0. You know the derivative is not 0. That's the only problem. Negative. So now I'm sure most of you have circled 1/2 as your answer, or 1/2 comma 24.5. But guess what? That eso es un mínimo. Minima? It's a minimum. No es bueno. So we need to use Candidate's test. I'm not doing this because I like to. We're doing this because we need to. When y equals 0, s equals what? 25. And when y equals 25, s equals 25 minus 25, 0, plus 25 squared, 625. So, when all is said and done, we want y equals 25 and x equals 0. Okay, that's it. All done. The rancher problem. Pretty famous. Try it out. 3, 2, 1. Did you pause it? Have you written something on your paper? Have you written anything? I hope so, people. When there's a diagram like this, I'm not going to label what's what. That's x, that's x, that's y. Okay? The first equation, let's see. He needs to enclose 320,000 square meters. Square meters is an area thing. The area of that shape is x times y. That needs to be 320,000. And what dimensions would require the least amount of fencing material is a perimeter thing. So I'll just call it P. It'll be 2x plus y. They're both pretty easy to solve for. They're both pretty easy to solve for. They're both pretty easy to plug in. Y is a bit easier. It's not multiplied by anything. 320,000 over, I'm so sorry for that, x. So my new and improved perimeter equation is 2x plus 320,000 over x. The domain of x. Well, guess what? Based on the context, x has to be strictly bigger than 0. If x were 0, you would not have a fence enclosure. If x were negative, we'd have a bigger problem. Is there a maximum value for x? No. Why? Because if x was a million bajillion, y would just be 320,000 divided by a million bajillion. And guess what? That's still some positive number. It's really tiny. At that point, there's no reason to even have the fence. But we have to consider it when we do our calculus. So that's P. P prime is 2 minus 320,000 over x squared. P prime equals 0. Would give us the equation 2 equals 320,000 over x squared. X squared equals 160,000. Yeah, like that. Which I believe these is what x equals 4,000. Or negative 4,000. I'm not going to use my foolish pride. Hubris will be the death of you all on the AP test. Notice how little of my math I do in here? I don't do 2 plus 2. I swear I've seen people do that in our class. Clear, square root, 160,000. 400. See? Math is terrible, huh? 400 and negative 400. Whatever. Did I really type it in right? I can't even believe that. That's so stupid. Numbers are dumb. 0 is also a critical number, but it won't matter. It's not part of our domain. So, here we go, people. I'm deciding the color to use. 0 on to infinity. with 400 smack dab in the middle. Between 0 and 400, what kind of number is this going to be? Guess what we get to plug in? 1. It's going to be negative. After 400, it's hard to think about, but guess what's happening? After 400 is when this hits a big number. Okay? Right? We can plug in any value I want. I can plug in 1,000,000. 1,000,000 squared is definitely going to make this number a fraction. It's going to be positive. So is 400 a minimum? Yes. So x equals 400. Y equals... Don't tell me. 800. Boom. Oh, come on. I knew it was 8,000. I'm so bad at arithmetic. Not as bad as you guys, but man, apple doesn't fall far from the tree, huh? Alright. I knew it was 1,000. Oh, it's so dumb. I'm so sorry, everybody. Okay, well, that's it. That's that. Try this one out. Maybe you'll do better than me. It's okay if you need to use a calculator like that to check your work, okay? But the point is I can do it without a calculator. I'm just, it's 9:30 on spring break. Let's just say it that way. Pausing the video, you're trying it out. 3, 2, 1. Rectangle. Well, we should let things equal the width and y equals the length. So this will be confusing because maybe you did it differently. It shouldn't be that confusing. This should be a square. Your answer. There. Is that good enough for you? So 2x plus 2y should equal 80. And in terms of, I want to maximize my area, which should be x times y. Both easy to solve for here. I'm going to go with the usual. I like x better. 2y equals 80 minus 2x. Y equals 40 minus x. So our new improved a equals x times 40 minus x. I consider domain before simplifying. Well, it surely is not going to be a rectangle if x is 0 or less. And if x gets bigger than 40, y stops being a nice side also. Okay? So, we're stuck with this domain. Open endpoint bounds. That's what I like to see. Oh boy. A prime. Guess what? It's going to be 40 minus 2x. So a prime equals 0 when x equals 20. And for once, 20 is actually halfway in between. Between 0 and 20, we're talking about like 10. Positivo. After 20, we're talking about like 30, so negativo. Meaning 20 is a maximum. X equals 20. Y equals 20. I told you it would be a square. There's a general theorem. You could prove it at this point with calculus. That if you have a rectangle and you're trying to maximize the area, the maximum dimensions of a rectangle. The area maximizing dimensions of the rectangle for a given perimeter is a square. Just a nice little theorem. Notice that this rectangle wasn't like that. But this rectangle was such that... Still suspicious about that. $160,000. But, okay. This rectangle wasn't equal share of this, right? This rectangle had it so that these had an unequal share of the widths, of the lengths. Does that make sense? I paused the video to prove to you it had to be 800. So go back to example 3. See, I don't know how I got 8,000. I'm very excited about that though. There's no way to check the history though. It's 800 here. And because guess what? If you add up x and x, you get 800. It's still equal to y. So that's the theorem. I don't want you memorizing tricky ways of doing it. It's okay just to prove it each time. You're fine. You're fine. That's 800 though. Here's another example of it. So you can think about what that trick would say, but again, I don't need you doing it that way. I need you to be able to do the calculus. Label's already given. 3, 2, 1. Did you pause the video and try it? Pause it right on a piece of paper. Do it, do it, do it. You got this. I believe in you. Here we go. 240 feet of fencing total. Now, this is the question that everyone will mess up on. So, all of this perimeter was 4x plus 3y. That had to be 240. And the one everyone misses is right here. So if you mess that up, try it out again. Alright, 1, 2, 3. I hope you're really trying, people. The area equation, which is what I want to maximize, is x times y. Nope, it's 2x times y. The entire length times the entire width. Okay. Which is going to be easier to plug in? It really doesn't matter in this case, everyone. Technically, I like to get rid of the y. That's just how I roll, people. Like I said, I like the x is better. So I'm going to solve this for y. X is easier because you're used to working with it. I hope you wrote it like this. This is a lot easier to work with than the other. So my new and improved area equation would be 2x times 80 minus 4/3 x. This bad boy's domain. X certainly needs to be a positive number. It cannot be 0. And it's going to top out at whatever would make y 0. Because again, y needs to be an actual side. What would make y 0 here? 60. 60 divided by 3, 20. 20 times 4, 80. Now I'm going to simplify. 160x minus 8 thirds x squared. So a prime would be 160 minus 16 thirds x. A prime equals 0 when x equals 30. Does that make sense? 30 times 3, it's divided by 3, 10. That's not my final answer. Open, open. 30 is actually in the middle for once. How interesting. Now, between 0 and 30, we're talking about 10. Or, I don't know, 3 is really easy to plug in, right? Positivo. After 30, I don't know, 33 is easy to plug in. It's not the most easy to plug in, but it's something like that. It's negative. In general, you know this is an odd 0. That's another way of doing it. It has to switch here. So it was increasing, then decreasing. X equals 30. Y equals what? What's that you say? 40. You should get that no matter how you do this problem. Next. The shelter problem. The one you all hated. Try it out. Pause the video. Do it as best as you can. You can beat it this time. 3, 2, 1. Here we go. 3 plexiglass sides and a plexiglass top. The volume of this shelter is definitely x squared times y. 1 side, 2 side times 3 side. Okay? The surface area of the shelter the 486 cubic feet would have been comprised of these 3 sides, which are all xy's, plus an x squared back. It does have a back. These 3 sides, like some students wanted this to be colored in, I guess, but it's a little bit tricky with your eyes. Just saying. Alright, again, y is easier to solve for down here. It's also easier to plug in. I'm just going to solve for y. 3xy equals 486 minus x squared. Y equals 486 minus x squared over 3x. Ugly, ugly, ugly? Sure, but not that bad. It's really not that bad overall. Trust me, boys and girls. It's gonna be great. So, the volume equation that we're really interested in. X squared times 486 minus x squared over 3x. Complicated little shape here. Domain. X has to be bigger than 0. But still, it wouldn't make any sense. This is harder to solve for. There's some max value. There's some max value that would cause a problem. I actually believe it's the square root of 486. It's what would make this top 0. Okay? But I'm not sure that's a nice number. Is it a nice number? This is how you use your calculator, people. This is a nice number. See? Told you so. Okay, so now that we're considering that, I'm going to simplify this completely. I'm going to get 486 is divisible by 3 because 4 plus 8 plus 6 is 18, and that's divisible by 3. So what's 486 divided by 3? 162? No. Minus x cubed over 3. Okay. Okay. So v prime equals 162 minus x squared. So v prime equals 0 when x equals the square root of 162 or the negative square root of 162. But this one's out of the domain. Gross. I'm putting the square root of 162 right here. Now, what's a number a little less than the square root of 162? 10. Right? The square root of 100 is less than the square root of 162. We're just thinking of a nice number, like 10. What happens when 10's plugged in? Positive number. When a number is slightly bigger than 10, like 13's plugged in, negative number. Yes, I just did this round wrong, so I'll either edit it out or, I don't know. It's good for you guys to see I can mess up too. I don't know if it's good to make the video longer because of that, but okay. The volume. Okay, no. If I'm going to leave it in. Why do I know I messed up? This is a maximum. These numbers are ugly. That was already making me upset earlier. But this is a maximum, and these endpoints are never reached. So there would not be a least. Okay, there would not be a least if this was the maximum. So this is all trash. Now, why is it trash? Because I can't read either when we're just doing work half-butted. The volume of the shelter is capped at 486 cubic feet. So the equation I should have there is 486 equals x squared y. Now, the surface area of the sheet is what I want to... The surface area of the plexiglass is what I want to maximize or minimize, and that's x squared plus 3xy. And again, that's based on there are 1, 2, 3 sides going around this way and a top. These 3 sides, the left, right, and top, have dimensions x, y. The back has dimensions x squared. Now, who do I want to solve for? I want to replace y in this equation. Okay, so here I go. In order to replace y, I solve for y. Obtaining my new equation, a equals x squared plus 3x times 486 over x squared. Alright, now domain. So I'd be worried about not having a height or a width. That wouldn't really be a bus stop. But is there any maximum value I can put here? Nope. Because if x was 1,000,000, y would just be a really small number, but it would still be a number. Now, we know it's not really going to be that high, but it's going to be, something. So now I simplify a equals, whoa, gross. Plus 3 times 486 is 18, 5, 140, 100, yeah, something like that. See, this is a good example of not using your calculator, because you're usually not allowed to. Minus. See how much this trick has come into play? I talked about at the top of the video. If you just know this, you'll be sped up so much. It will be unbelievable. So I want to solve when a prime is 0. This is a big problem for some people. Okay, that 5 was an 8. But there's no reason for it to be. Because I believe in you guys. Multiply both sides by x squared is okay. You're technically leaving out a solution, but it's okay. We'll worry about that at the end. 1458 equals 2x cubed. And x cubed equals 4, 7, 7. No. I did it the wrong way. 729? And that means x would be 9. Yay! Another critical number to consider would be 0. But 0 is not in our domain. Why is 0 a critical number? Because 0 would make the derivative undefined. I picked a different color for a reason. Thank you for working with me. 0 toward infinity, with a nice 9 in the middle. Before 9, what are we looking at here? Just plugging in a nice 1, 2, minus a billion, bajillion, negative. After 9, I don't know, 100. This will be a small fraction. Decreasing, increasing, x equals 9 is one dimension. Y equals, oh man, 486 divided by 81. Is that a nice number? Yeah. No, it's a great number. It's going to be like, let me see. So, 5, 54. 54 divided by 9, 6. See? I can do math in my head. Boom. Don't close it. Okay. Yeah. Did you get it? Did you do this? Did you do it right the first time, unlike me? Okay, this one was also hard. Give it a second. Try it out. Do your best on it. Pause the video now. Really try and come back. Alright. So, 12 material, square material, 12 inches on each side. On each side. That's where this 12 is coming from. Find the length of each side of the square cutouts that will produce the greatest volume of the box. So I found when I was tutoring people on this problem, they had a hard time picturing what this box would look like. So I'm saying we cut out this corner, this corner, this corner, and this corner. And then we kind of fold up along the dotted lines. I'm no artist, as you all will tell me on a regular basis. But something like this. Where this is 12 minus 2x. This is 12 minus 2x. I know it's a proportional, but that's the price we pay for a relatively good looking picture. So what would the volume of this side be? It would be 12 minus 2x quantity squared times x is the height. Part of the problem is getting that. If you didn't get that, pause the video, redo all your work, and try again. Alright, now, greatest volume box. Either you're sitting there, you're going to do that, or you're going to really simplify it. But first, let's talk about domain. X, the size of the cutout. There's no box without a cutout. So it has to be bigger than 0. Right? If this was 0, it would just be a flat piece of cardboard. On the other hand, if x became bigger than 6, then this cutout would stretch to the midpoint, this cutout would stretch to the midpoint, and there'd be no more material. You would have cut out the whole box. That's huge. Okay. Simplify. 144 minus 48x plus 4x squared times x. 144x 48x squared. You can use the product rule if you're feeling good about that. Maybe you should have, just to test your might. So v prime equals 144 minus 96x plus 12x squared. I'm going to factor 12 out. 8. Keep on factoring. 6 and 2. So the critical numbers, the ones that would make v prime 0, x equals 6, and x equals 2. 6 is not in the domain. It's very helpful for us to know that. This analysis, which I'm going through quickly because I understand what's going on, is huge. There's 2. Now, before 2, we're thinking about something like 1. Negative number, negative number. After 2, positive, negative number, positive number. So the greatest volume is at 2. So that's how much you're going to cut out from each side of the square. What does that leave? How long will this be? 8. Okay? Okay. Donezo. Try it out. 5 minutes. Go. Give yourself 5 minutes. Time yourself. Go, 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 go. 3, 2, 1. Alright. I'm assuming you tried it. I can't watch you. Yes, they can watch you, but I can't. Alright. What's the area of that rectangle? That would be x, y. How can I simplify this to only have one variable? If only, and this is how I would teach people, tutoring people, if only they gave me some other equation that related x and y. If only they told me y in terms of x. If only there would be some way to replace the y in this equation, is what I would tell these people. Boom. Negative 1/2 x squared plus 3x. Oh, I didn't do my cardinal rule, where I always check the domain first. I'm in the first quadrant. So x had to be greater than 0? Well, what do we think is the first quadrant? Is the axis in the first quadrant? I think it's not, technically. I don't know for sure. Now, if x became bigger and bigger and bigger and bigger and bigger, nope. There's this intercept right here. Okay. What's this intercept? The y-intercept here is 6. Sorry, the x-intercept is 6. And you're stuck between them. If x got bigger than 6, we'd be on this line down here. So now, a prime negative x plus 3. Whoa, equals sign, buddy. A prime equals 0 when x equals 3. Between 0 and 6. 3's cozied in halfway between. And a positive and a negative. Maximized at 3. Pretty much like we wanted. X equals 3. What would y be? Y would be 3 halves. Ugly but true. That's a point. If I wanted to write the point, it would be 3 comma 3 halves. Dodoy. Moss, problemos. Oh, this one's great. I love this one. You try it out. See how much you love it. It's amazing. 3, 2, 1. 36 total inches of wire is used to form the perimeters of these two. So that 36 had to be all for x and the 12y there. Just adding things up. Now, I want to maximize and then minimize. Oh, no. Careful. Try it again. Did you get both? Did you get both? Pause this video and try it for the first time, maybe. Okay. Now, the total area. My area equation in either case would be x squared plus 6y squared. Why is 6y squared? Half base times height. Both are a pain to substitute for. That's just the harsh truth of the world here, folks. I'm going to substitute for y. Oh, y is so much harder, though. Let's do x. What's, why not? Variety is the spice of life, folks. We haven't been big on folks this break. I'm so sorry. Alright, so 9 menos 3y a 2, 6y squared. The domain here. What is the domain? Well, y certainly has to be bigger than 0. No, it doesn't. Why not? Because if y were 0, it would mean the best version we could get is by killing the square. Or sorry, if y were 0, yeah, it would be killing this rectangle, this triangle. And that's okay. I'm going to say that's playing by the rules here. It doesn't say we have to have both. It says and or, in fact. That and or for sure is telling me we don't necessarily have to have both. Now, alternatively, if I used all the perimeter for y could only top out at 3. Because if y were 3, this would be 36, there'd be nothing left for the square. Okay? Okay. I'm going to show off my calculus skills. I'm not going to use foiling. I'm just going to use the power rule with the chain rule. Times -3, the hook on, plus 12y. And now I'm going to simplify this. So much less of a headache. Man, isn't calculus wonderful? Isn't the world magical? That's not magical. Good. So a prime equals 0 when... Did you guys get this? Are you seeing what I'm seeing? 54 over 30? Okay. They're both divisible by 6. 9 sobre 5. Okay. Gonna trust these numbers? Well, I'm not trusting them really. I'm checking again. But I'm pretty sure that's right. That's right. Plugged it in. Alright, banging. Here we go. Let's do it. 0 included. 3 included. 9/5 is between there. That was one thing I was worried about. It's definitely less than 3. In case you're all freaking out, this one's -54 plus 30. Why? That'll be easier to plug this stuff in. 1's over here when x is 1, or when y is 1. We have a negative value for a prime. 2 is over here. We have a bigger. So naturally, this is at a... Shoot. Naturally, this is the minimizing. That's the minimizing. So y min area when y equals 9/5, x equals I really can't believe this is right. 45/5 minus 27/5. 18/5. Does that equal 36? These are the checks you can do. I'm just plugging this number back into here. Making sure everything works out. That everything is copacetic. 4 times 18, 72. 72 plus 108, 180. 180 divided by 5, 36. Alright, it's all checking out. So that's the minimum area. The good one. Now in black, max area. We need the candidates test. So when y equals 0, and when y equals 3. When y equals 0, what sort of area are we getting? This guy is 0, that guy is 81. When y equals 3, this guy is 0, that guy is 9 times 6 is 54. So y equals 0, x equals 9. And we needed the candidates test to show that. And that's surprising. Well, to me it is. It's just best to put all your perimeter into the square basket. Who would have thunk? A box with an open top has a square base. Volume of the box is 4,000. What dimensions minimize the amount? Go for it. 3, 2, 1. I'm going to draw my picture. I know. It's going to be hideous. I'm sorry for this artistic hate crime. Wow, it was okay until the last one, I guess. Square base, x, x, y. Volume of the box, 4,000 equals x squared y. Material has always been area. And this guy has x squared the bottom plus 4 sides, no top. Y is going to be easiest to plug in here. So let's solve this puppy. Y equals 4,000 over x squared. So our new improved surface area function. X squared plus 4x times 4,000 over x squared. Domain. X can't be 0 or anything less. It's a real world box. If x got too amped up, no, there's no top. I'm sorry. It can be as big as it wants to. Y will just have to compensate by being as small. Okay? So, simplifying. $16,000 over x, and therefore a prime and again this trick comes in handy. Now this is not as helpful as we want. We want to set a prime equals 0. 0 equals 2x minus 16,000 over x squared. 16,000 over x squared equals 2x. X cubed would equal 8,000. X equals 20. Those are my critical numbers. 0 is another critical number, but 0 is not in the domain I'm interested in. Why is 0 a critical number? Because it would make a prime undefined. Number line time. Numero Munia. 0 to infinity. 20 in the middle. 1's over here. I don't know. A million's over here. The point is, this is going to become really small. That's going to become really big. So x equals 20 does minimize the area. And that would leave y with 10. There you go. Oh, y equals. I would mark that wrong in a heartbeat. The second of two positive numbers. Oh, sorry, I didn't know. We should look at it. Pause it if you want. Pause this and try it out. 3, 2, 1. Labels are fundamental. The second of two positive numbers is the reciprocal of the first. Y equals 1 over x. That's hard for some people. That's the whole game right there for some people. Now, of course, that means the other relationship holds too. But I think a lot of people can't get there. So we want their sum to be a minimum. So the sum of those two numbers is x plus y. The new improved sum is x plus 1 over x. The domain for this function. So if they have reciprocals, it can't be 0. Also positive. But there is no upper bound because as long as x is positive, y will be positive in this world. Okay, so now I want s prime. 1 minus 1 over x squared. S prime equals 0 when x equals 1 or negative 1. Negative 1's not in the domain. Number line. 0. Off to infinity. I can't believe it. I make nice arrows. I do when they filled in like that. I should just always fill it in. 1. Okay, maybe this is hard for you to tell. X is a teeny number. When x is teeny, what's going on? This is positive. When x is a big number. Whoa. Other way around. Negative. When x is a big number. When x is like 100, this is a tiny number, and then this is positive. Decreasing, increasing. X equals 1, y equals 1. That's the best you're going to do. Makes sense. Okay. For the sum to be minimized, 1 is the natural minimum here. A few more problems. Rock cliff. One more time. This time, it is perimeter. Spoiler, sorry. Try it. Pause it. Pause it. Pause it now. 3, 2, 1. 1,200 yards of fencing to use. 2x plus y had to be 1,200 yards. I want to maximize the area, which is xy. If I solve for y, it would be 1,200 minus 2x. And therefore the new area function I get is x times 1200 minus 2x. The domain of this little function. Clearly x has to be a positive number if it's the side of a rectangle. Is there no end of x? Yes, there is. If x was bigger than 600, why wouldn't it be a side? Because we've used up all of the perimeter, all of the fence just to make these two sides. Okay. Simplifying. Differentiating. Look how I label all my work. And I know it just sounds like I'm bragging, but I'm not. A prime equals 0 when x equals 300. Let's make a number line. That is one crooked line. One's over here. And then this will be a negative number. So we're increasing and then we're decreasing. Okay? So x equals 300. Y equals what? 600. What is the maximum area? What's 600 times 300? It's some ginormous number. 180,000, I think. Ta-da! Last one. Okay, this one gave a lot of people trouble, but it's a common AP test problem. So try it. Give it your best shot. You just watched me do like an hour of this. Go for it. 3, 2, 1. Okay. First things first, folks. What's the area of this rectangle? The area of this rectangle happens to be 2xy because of this x here. Now, if you didn't get that, try it again. Now, what's our secondary equation? Our secondary equation was lurking there all along, leaving our area equation that we're actually going to use to be 2x times cosine x. Okay. What are the domain of this function? 0 has to be less than x. X had to be some positive number to get this rectangle. X can wander all the way over to this intercept. What's the intercept for cosine? You should have said pi over 2. If that's a prime, first times derivative of the second, plus the second times the derivative of the first. Reorganize. Plus 2%. Alright, this is a hard part for some people. A prime equals 0. 0 equals 2x minus 2x sine x plus 2 cosine x. Now, you would never be able to find the zeros of this function. You may use a calculator, but only to solve an equation. That's what I'm referring to. If you use a calculator for anything else, you are doing this wrong. How can I use a calculator to solve this equation? None of that. Mode. You want to be in funk. If you're in AB, you should always be in funk. You've got to keep it funky. Okay, here we go. Negative 2x cosine sine x. See, I have the equation written down. That's what they mean by solve the equation. Nothing else. It's an old operating system. Don't freak out. What's the window? What's the window I'm interested in? I'm interested in my domain being between 0 and pi over 2. I'm interested in the solutions between those two values of x. That bins and max is fine. If you want to be looking at the same graph I am, you should have that in your calculator. But you already did this problem, so what am I talking for? Graph. We're looking for where it equals 0. Boom. That crossing point right there. That's what I'm interested in. Second, calc. 0. Left bound. I want the spider to be left of that crossing point. Enter. Now I want to get it right of the crossing point. I want it to cross from a positive value of y to a negative value of y. Enter. Enter. 0.860. 3 decimal accuracy. This is what they want. They want this work. I want this work. If you do not have work that looks like this, you messed up somewhere. 0. Pi over 2. 0.860. Before 0.860, what is the sign of the derivative? The sign of the derivative is positive. It's above the x-axis. After that point, it's negative. So I want 0.860 for my x value. And my y value should be what? My y value should be the y value at that point. Not on this graph, but on the original graph. Second, quit. Notice that under answer is my value. And what do I want to do? Y equals the cosine of that. 0.652. You should write it as an ordered pair. Did you get this? If you did, consider your training complete. If you didn't get a lot of these, watch this video again in 2 days. See if you can make an improvement. It's not just about knowing the answers, it's about knowing how to get the answers. I appreciate all of your hard work. Good job watching a video in your free time. I hope you are trying the problems out yourselves. If you need help on anything additionally, or if anything was unclear, please come talk to me in person. I'm happy to help you, especially if you're working this hard to watch a video, like an hour-long video, in your spare time. Thank you for your dedication. Have a great day. I'll talk to you soon. Bye-bye.